somewhere out there, far beyond the edge of everything you can see, the James Webb Space Telescope is staring at something. A structure so vast that light itself takes 10 billion years to cross it. A structure that, according to the laws of physics we've trusted for a century, shouldn't exist at all. It's bigger than our galaxy, bigger than our supercluster, bigger than the part of the universe we've ever been able to map. And tonight we're going to walk straight up to it. To understand what Webb is looking at, we have to start somewhere familiar. This is home, 8,000 miles across. The entire history of every person who has ever lived, every empire, every love story, every war, fits on this single blue sphere. Now zoom out. The sun is 109 times wider than Earth. If our planet were a grain of dust, the sun would be the size of a basketball. But the sun is just one of 400 billion stars in our galaxy. To even see our galaxy from the outside, we'd have to travel for 100,000 years at the speed of light. Here it is. The Milky Way, our home in the cosmos. And here's the part most people don't realize. The Milky Way isn't floating alone in some empty void. It's part of something much, much larger. And the deeper we look, the stranger it gets. This is the local group. About 80 galaxies bound together by gravity. The Milky Way is just one of them. But the local group is part of something bigger. A neighborhood within a neighborhood. We call it Laniakea, the immeasurable heaven. A supercluster of over 100,000 galaxies, all flowing slowly toward a single mysterious point we still don't fully understand. Called the Great Attractor. And Laniakea? It's just one bead on a thread on a web. This is the Cosmic Web, the largest structure ever directly observed. Galaxies are not scattered randomly through space. They're strung along invisible highways of gravity, like glowing cities along an infinite nervous system. If you could shrink the entire observable universe down to the size of a city, every galaxy you've ever heard of would fit inside a single dust grain on a single street. But somewhere on that cosmic map, at distances we can barely measure, Webb has spotted something that doesn't fit the pattern at all. The James Webb Space Telescope is the most powerful eye humanity has ever built. It doesn't just see further than Hubble. It sees backwards in time, watching light that left its source billions of years ago. And in the past few years, surveys using Webb, along with other telescopes that came before it, have been quietly mapping the largest patterns in the sky. What they're finding is unsettling. In one region of the sky sits something astronomers call the Giant Arc, a colossal curve of galaxies spanning over 3 billion light-years. Nearby, almost on the same patch of sky, sits the Big Ring, a near-perfect ring of galaxies more than 1 billion light-years wide. And then there's the granddaddy of them all, the Hercules-Corona Borealis Great Wall, a potential structure of galaxies so vast that, if the measurements hold up, it stretches across 10 billion light-years of space. To put that in perspective, the observable universe is about 93 billion light-years wide. This single structure may span more than 1/10 of everything we can see. And here's where the problem begins. For nearly a century, our entire understanding of the cosmos has rested on a single, elegant assumption. It's called the Cosmological Principle. And it says something quietly powerful. On large enough scales, the universe should look basically the same everywhere. No special places, no giant outliers, no cosmic continents. The math works beautifully. The Big Bang model, the expansion of space, the cosmic microwave background, all of it depends on this one idea. The cutoff most cosmologists have used is around 1.2 billion light years? Beyond that scale, the universe is supposed to look smooth, featureless, predictable. But the giant arc is more than twice that size. The Big Ring is larger still, and the Hercules-Corona Borealis Great Wall, if confirmed, is nearly 10 times bigger than the limit our theories allow. These structures appear to be too large, too organized, too old, and they shouldn't be there. Now, to be clear, this doesn't mean physics is broken. It doesn't mean Einstein was wrong or the Big Bang didn't happen. But some scientists argue that if these structures are real, and that's still being debated, our picture of the universe may be incomplete in a deeper way than we realized. Maybe the early universe wasn't as smooth as we thought. Maybe gravity behaves differently across truly enormous scales. Maybe there's a piece of the puzzle we haven't found yet. Or maybe the universe simply doesn't follow the rules we wrote for it. There's something deeply unsettling about discovering that the universe is more organized than it should be, because every structure we see today had to grow from tiny ripples in the early universe. Variations so small they're nearly invisible in the cosmic microwave background, the leftover light from the Big Bang. To form a wall 10 billion light years across, those tiny ripples would have had to grow into something gigantic in a fraction of the time we thought possible. It's a bit like discovering that a single drop of water somehow shaped an entire ocean. If these structures are real, they raise a difficult question. Is the universe older than we believe? Did gravity once work in ways we no longer recognize? Or are we looking at the fingerprint of physics that has not been written yet? And here's the part that should stop you in your tracks. The observable universe, everything Webb can ever see, is only the portion whose light has had time to reach us. Beyond that boundary, the universe almost certainly continues. Possibly forever. Which means the structures we're already calling impossibly large might be the smallest features of a universe we have not even begun to map. For most of human history, we believed Earth was the center of everything. Then we learned it wasn't. We believed the sun was special. Then we found out it wasn't. We believed our galaxy was the entire universe. We were wrong about that too. And now, in our own lifetime, we're staring at evidence that the universe itself, the laws, the scale, the structure, may be something far stranger than we ever guessed. The James Webb Space Telescope hasn't broken cosmology. It hasn't proven Einstein wrong. What it's done is something more humbling. It's shown us once again that the universe is bigger, older, and more mysterious than the models we built to contain it. So the next time you look up at the night sky, remember that what you can see is only a whisper of what's actually out there. And somewhere far beyond the edge of light itself, something enormous is waiting to be understood. If this journey made the universe feel a little bigger than it did 10 minutes ago, subscribe. Because on the cosmic scale, we're only just beginning to zoom out.